Yes, this is hard, but yes, every single one of you can do this.
Is 4 pieces of paper adequate?
Yeah, 4 pieces of paper may be adequate. It might be.
Like
Lord knows, who knows.
lesson or one plan?
For this one lesson, this one's going to be a lot of writing. It is going to be a lot of writing. It's a lot of steps. It can be a lot starting out, but you all can do this. Each individual step is not that bad, I promise. But it is, you can be a little intense.
Great pep talk.
I think that's what the chapter in the book's called. I'm going to title this The Rational Root
You're
Theorem.
not putting that.
And yes, Hannah, what is your question?
You know, like they can't see the whole word.
Guys, too loud. Yes, Hannah?
What are you doing?
It's too bright. Light.
So
That's
that's
a
a
good
good
hard
question, Hannah. What we did on Friday doesn't directly apply here. Woodrow, ignore Junior. Let him do his thing. What we did on Friday won't be used directly here, but what we did on Monday and Wednesday with the synthetic division, that comes up a lot. The synthetic division will come up a lot. Okay,
Yeah.
that works. Okay, let's do this, y'all. The rational root theorem.
Rational, irrational.
So we're doing irrational.
What are y'all talking about?
So we're going to do the irrational root theorem.
I don't know if that's a real thing or not. If it is a real thing, it's probably pretty cool. But we're going to keep it in the realm of rational today. We're going to keep it in the realm of rational. All right. So first things first, before we even get to the theorem, we got to build up to the theorem. This one's a big one. First off, we're going to make sure we can do some very mathy things. We'll just review some terms here. We're going to review some terms. All right. Linear functions. We know what these are. These are nice and friendly. Can someone give me the general form of a linear equation? Raise your hand. Yes, Christian?
Makes a line.
That's what it is, yes. But I mean like the mathy, nerdy way of writing it. Yes, Brayden.
MX plus B.
MX plus B, exactly. I'm going to write it a little different just to make it look similar to what comes after. I'm going to write it as f of x equals ax plus b. That's the general form of a linear equation. We're plenty used to doing that. And we got other kinds of functions and polynomials that we know how to deal with now. We know about quadratics. Could anyone raise their hand and tell me what a general form of a quadratic looks like? Sydney?
A squared plus b x c.
I get it.
Is it
You basically got it, but the Pythagorean theorem got in there somehow. Yes, Christian.
AX squared plus BX plus C.
That's what we're looking for.
Equals 0 or
That's
no?
okay.
Equals 0 or no?
That would be standard form for an equation. For a function, it's not required. F of x equals ax squared plus bx plus c. That's why I used a here, just so it looks similar to this. All right, and then we can keep playing this game. We got stuff after quadratics. Anyone know the name?
Long division thing?
Yes, Junior. Long equation. Yes, cubic. Cubic comes next. And spoiler, the cubic will be the star of today after a while.
Yay.
The cubic function. This is any polynomial with an exponent of 3. That's its highest. Its general form looks like so. Ax to the third plus bx squared plus cx plus d now.
So it's just it's a quadratic with a cube added to it.
Yeah. Okay. You could keep doing this naming thing forever. We really stopped giving them specific names after like 5. So I'll just write down one more of these. I'll write down the quartic, and then I'll write down the real scary bit that I hope won't scare you too much. Right. The quartic, so by recognizing that we're just counting here, 1, 2, 3, 4. This is any polynomial with an exponent of 4. So this one looks like this. Ax to the 4th plus bx to the 3rd plus cx squared plus dx plus e now.
So this just goes on forever.
That goes on forever. But it's kind of tedious, kind of annoying. if I wanted to write down the general form of like a 12th degree polynomial, it'd kind of suck to do it like this.
Yeah.
And some of you may not agree, but that is why mathematicians come up with a more general way to write a polynomial function. And that's what I'm building to here. Okay, so if I'm just gonna put a little dot, 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 that means like this pattern continues on forever. But in general, a polynomial function, so a polynomial function of degree n, is going to look like the following. And I'm going to use capital P of x here just because it's big and fancy and important. This is going to be... Junior, make this madness stop. Oh, it's actually Isaiah.
Oh, he's
He was calling.
oh my shit.
Nah, you know.
In the middle of math.
Yeah.
Okay, my P of x is going to be, stay with me now, a sub n.
Slow down. I'm still
Wait,
writing polynomial function.
Already.
No, guys. No, stay with me now.
Wait.
Stay with me now. I'm going to say it again. I'm going to say it again. Calm. Sarah,
Is
yes.
the N like a subscript kind of thing?
Sarah, say that louder.
The N is a subscript.
The n is a subscript. Sarah is exactly right. This is just a little
So
counter.
we're doing chemistry now.
A little bit.
Yeah.
Yes, Cole. Do you have a question?
I was just getting comfortable.
I got you. Okay. So yes, don't freak out. This is just a variable. The way I pronounce it, a sub n. That's what I'm saying. A sub n.
Is that a capital P?
What?
Is that a capital
Oh, he already said that.
A was sub capital
He
what?
already said that. It was just picking up more.
Oh, yes. Capital P.
So why are you using P?
It doesn't matter. It's just a naming convention. P for polynomial.
Not ace.
Yeah, I thought you
Is
said
it
eight.
working, Junior?
Yeah, it's.
A sub N.
That's
I
what
think
I
I should
heard.
send it to
Yes,
you.
the way I pronounce this is a sub n. I'll keep writing once I know for sure this is working.
A with sub n.
It's not.
Keep space down.
Okay, Junior, is it recording or
Yeah, it's recording.
Okay, that's good enough.
He's pumping up the quality.
Skedaddle.
Junior.
Alright, shut up.
Okay, yeah, okay. All right, a sub n times x to the nth power.
There's more?
Oh.
And again, what I'm doing here is I'm writing down
Oh.
a form of a polynomial
Good
for an
God.
nth degree function.
Love it.
So any,
What is N?
David, stop doing that.
Why N?
Yn, I'm just choosing a variable. I could have picked t. I'm just using n.
Okay.
I'll show you what this looks like for a certain number of n. But let me write it down first. All right. A sub n times x to the n plus a sub n minus 1, so the previous coefficient, times x to the n minus 1, the previous power, plus a sub n minus 2 times x to the n minus 2,
I don't like this.
So on.
You're gonna have to slow down.
so on and so forth, all the way down, to a1x plus a naught.
What?
That's the general form of a polynomial function for degree n.
Yeah, so what we're gonna do is.
So what we're gonna do is crush it, because we're all awesome
No,
algebra.
we're not.
Wait, where are we going? How do we get to the 1 and the 0?
I don't even know what you just wrote on the board.
Guys, I promise, I will not make you memorize that. You do not need that on a test.
Survival.
Because it is important. And part of what I want to do in my time teaching y'all math is getting y'all used to interpreting scary stuff like this.
You need to do it on the SAT.
That too, and it's just,
It looks like some higher.
it's good brain workout. All right, quiet. Yes, Marlon.
So it's plus a with the subscript of n minus 1.
Yes,
And then the next x, is that just like,
that's the exponent.
no, it's like beside the n minus 1.
Yes,
There. Yeah.
that's an x beside it. Yes, it's like a sub n minus 1 times x to the n minus 1. Yes, Hannah. That is exactly correct. And that's exactly what I'm about to do. Okay.
No.
So I'm gonna show you how like this is useful, why we care. I'm gonna set, what did I pick? I'm gonna set n equal to 5 and show you how one of these kind of pops out. All right, so up here, let's set n equal to 5 for my p of x function here. Let's see what happens. Let's see how this works. Okay, so if I'm setting n equal to 5, then p of x is gonna be a sub 5. I'm just replacing all the n's with 5. A sub 5, x to the 5th, plus a sub 4 minus 1 times x to the 4 minus 1.
Wait.
Oh, good catch. Yes. Good job, y'all.
Oh,
We're paying attention. I love to see it.
okay.
No.
And we continue all the way down. Plus a sub 5 minus 2 times x to the 5 minus 2. Plus a sub, writing the wrong number again, 5 minus 3 times x to the 5 minus 3. Plus a sub 5 minus 4, x to the 5 minus 4.
This seems completely useless.
Boo-hoo. Plus a sub 5 minus 5, x to the
That should
5
give us
minus
a
5.
fair-
And that'll do it. Then I'll stop. Because if I go any further, I'll get negative exponents. Yes, yes.
Wait.
There's a pattern here. I started at 5, then it's 5 minus 1, 5
Well, yeah,
minus
I
2,
see
5
that.
minus 3, 5 minus 4, 5 minus 5.
So once you get to it minus itself, you stop.
You stop, yes. I could write some stupid condition here. I'm not going to bother with all that. All right. Doing some just quick basic arithmetic here. I'm just going to subtract all these differences. So I'll get a to the 5th, x to the 5th, plus a to the 4th, x to the 4th. And I think you can probably see the pattern here. A1x plus a0. So this big, long, scary form is just a way to generalize any polynomial of degree n. I could plug in whatever number for n, and out pops the general form of the polynomial.
God.
We doing all right?
Do you not put X
I need to
on the, wait,
No.
Okay, I hear distress. One question at a time. Yes, Sarah.
do you not add the X
Do I not add the x?
to the very end of it?
Oh, right here, this guy.
Yeah.
Here's the pattern. 5, 4, 3, 2, 1,
Last thought.
0, degree 0. So this is just a constant. Okay.
I need time
So-
to write all this down.
Yes, yes, yes. I won't write anything else down for a second. All I really want y'all to get out of this is just understanding how to apply scary looking math stuff like this. Not gonna make you reproduce this on a test. I'm not that mean.
You are.
I just want to practice using the math a little bit.
Wait, shouldn't the n be like a 0 x?
So what is the purpose of the
It's gonna
subscript?
be a bonus question.
One question at a time. What'd you say, Danny? I have my term with just x in it here. The term that comes after should have a degree less than this one. This has degree 1. This should be degree 0. So it is just a constant.
No, but where's the x at?
There is no x because it is just a constant. This is the term with the x in it. This is the term without the x in it. What's the issue? Yes. Yeah. Don't stress too much about it. It's just a constant term. Okay. What did you say, Aaron, was the purpose of the subscript?
Yeah.
Just to differentiate different coefficients. And it's nice because now the subscript matches the degree of the polynomial. That's why. There's other ways you can do it. I know.
But they matched already.
Yes, Aaron, I know. There's other things you could do. We use it because it matches. Yes, Marlon.
So the a with the 5 minus 5 is on the top line. You just couldn't fit it.
Yes, yes, I just couldn't fit it. Okay, let's return to planet Earth now. And let's do a simpler theorem that will build us up to the big, scary rational root theorem.
Leave that.
We haven't even started yet.
This was like a little aside.
I don't think I've ever been.
I thought this was like it.
Now, I'll say again, like, I'm not going to make you reproduce that on the test. Might not be a bad bonus question, but I will not make you reproduce that on a test. That is just a good start to this. Okay, now let's
Great.
look at an actual theorem. This isn't the big bad theorem, but it's going to help us get there. All right, this is the remainder theorem. This one's really handy and pretty simple, actually. The remainder theorem.
I'm sure it uses division, doesn't it?
Maybe. Okay. Now, one very good reason to start this out with this whole mess is now every time I write p of x, I just mean polynomial. Okay? So like from here on out, if I write p of x, I'm just referring to any general polynomial. That's all I mean.
Could you have written that out on your own, like off the top of your head?
This?
Yeah.
It's just a bunch of a's and n's. I mean, you know. All right. So if p of x is divided by x minus a, then the remainder is p of a, which is really, really handy.
You just get another variable.
Well,
How's that handy? You just get a variable.
I'm saying for any value of a. So like a would be an actual number in the problem that I gave you. But yes, this is very, very neat, very handy. I don't remember how to prove it, so don't ask me. But
Please
we can.
prove it for us.
Okay, Aaron. We'll see this in an example pretty soon.
What is
Do we have this down? Do we? Okay, okay. So a case where this is handy. Anytime I want to know just the remainder, nothing else. The question isn't saying divide these two things, it's just saying find the remainder. That is when this comes in handy. Find the remainder if p of x, which will be equal to the following polynomial, plus 2x minus 8, is divided by x minus 2. That is my problem. Write down the remainder.
Why he's so energetic today.
Is it just 3?
Okay. Okay. So well, here's what's going on here. I can use this theorem for this question, because what this is telling me is if I divide something by x minus a, here I'm dividing by x minus 2, then the remainder is just equal to taking the value of a and plugging it back into my function.
Oh.
That's what p of a means. Whatever number a is, it gets plugged into my function. So my value of a here is 2.
Or is it not negative 2?
It is not negative 2.
You just
That
did.
weird little thing we did with synthetic division where we kind of flip the sign, you do that here too. I like to think of it as taking this and just setting it equal to 0 and solving. That's how I like to think of it.
So x equals
2.
So x equals 2. So this is the number that gets plugged into my polynomial here.
So it's just gonna look like 3 times 2 cubed minus 4 times 2 squared.
Exactly. So what Braden said is absolutely right. If I want to know the remainder and nothing else, I can just plug in 2. 3 times 2 to the third minus 4 times 2 squared plus 2 times 2 minus 8. And that's boring baby math, so we'll skip all that. And if you put it in a calculator, you'll get 4. So the remainder is 4 if you were to do that division. And I think y'all can agree doing this calculation is a good bit quicker than doing a long division or something like that. Woodrow, no Woodrow,
Yes.
Wakey, wakey.
How Woodrow is also dumb.
No, Dwayne Woodrow.
Okay,
Wait, did I get negative?
you should not get a negative.
Property two or negative two.
Why do we do this?
Could you ever
When the
get a
hours
negative?
change?
No, the remainder should never be negative. Okay, we'll do another quick one like this of using the remainder theorem, then we'll look at a different theorem.
That's why it was dark outside when I was
Okay, find the remainder.
like, why is it dark?
When x to the fourth minus 6x cubed minus x squared plus 2x plus 7 is divided by
Ew.
x minus 1. That's the name of the game. That's what I want to know. Okay, got a polynomial. I'm dividing by something. I want to know the remainder.
Polynomial.
Tell me, Jackson, what do you think? What am I going to do to find the remainder here? I could do that. What's a fast way?
Bottom solve for x.
Bottom solve for x. Yep. That'll pretty obviously give me 1. What am I going to do with that 1? What do you say? Plug it in. Exactly. If all you need is the remainder, just plug it in. So this will be, oh, I forgot to give this a name. This should have been like p of x equals, my bad. So p of 1 is just plugging in 1 everywhere. So 1 to the 4th power, all the way down. And stuff like this, y'all, it's not hard, but I do see y'all mess it up sometimes. It kills me. Just careful when you do stuff like this. Don't type like 8 million things into the calculator. It will give you the wrong answer. Yeah, just be careful. It won't be too bad.
Mr. Davis,
Yes.
I saw a calculator online that only gives you wrong answers.
Oh, that's horrible. All right. If we skip all of the baby math, this will give you 3. Unless I made a mistake on the baby math like a week ago.
It's like, didn't we get a calculator?
Okay. I think that's good for the remainder theorem. Besides being terrified by the general polynomial function, we doing okay?
Someone put a body up.
That's great, Kaylee. Okay, let's continue.
You can't, Mr. Dave's the secrets. You can't release the secrets.
Not quite. The rational root theorem has pieces. We need to look at a different theorem first. We need to know what the factor theorem is.
How much space do you think this will take?
A lot.
This one?
This particular theorem, you mean?
Yeah.
Exactly the same amount of space as the previous.
Okay.
Yes, Junior.
Or the remainder theorem?
Yes.
Be a fraction.
Will the remainder ever be a fraction?
Like that over like x minus 1. Like 3 over x minus 1.
It should be possible, yes. Any problem I give you, I won't do that. Because, yeah, I'm not that mean. But I can't think of any reason why that wouldn't be possible. Yes, David.
So why couldn't we do this over several days instead of one big day?
Because there's no other way to do this but one big day. You'll see why. All this stacks up. Yeah. Okay.
Good to know.
Factor theorem. Okay, so similar kind of setup to before. So a binomial of the form x minus a is a factor of p of x if and only if p of a is equal to 0. So I have a strict useful condition that will tell me when a binomial is a factor of something. That is very handy. It is very, very handy. Basically, a translated version of this into just like basic English is if the remainder is 0, then you have a factor. That's all it's saying. If the remainder is 0, that's what this part is saying. This is saying if the remainder is 0, then x minus a is a factor of p of x. That is what that theorem is telling us.
What's a factor?
Okay, a factor is part of something that multiplies to the bigger piece. That wasn't a very good way to say that. So think of it this way. For like the number 49, 7 is a factor of it because 7 times 7 is 49. Different number, maybe 63. 9 is a factor of 63 because you can multiply 9 times 7 to get to 63.
And you can divide them and get a 0 remainder, and that's how you know it's a factor.
Oh, Christian, I like that. Tying it back into this definition. That's 100% correct. Nice job. Okay, yes, that's what a factor is, Caleb. Okay, that's very handy. Let's see it in action before we go absolutely wild with it. Yeah, this will go up here.
Wait.
Yeah, Woodrow, you really don't want to miss today. Okay, so I want to determine
How much paper am I gonna?
a lot.
Wait, would this be problem number 1?
If you want to consider it the first factor theorem problem, yes. Determine whether x plus 2 is a factor
Well, I'm not saying that's much. I'm not thinking.
of p of x equal to the following. X to the 4th plus 2x cubed plus 2x squared plus 3x minus 2. Y'all write that down. I gotta take this jacket off.
Oh, is it toasted?
Christian, he's taking off the coat.
Actually, no, yeah, we'll crack the door. It's really hot in here.
Stripping.
Aaron. Aaron. Lord knows.
The door just shut itself.
Are you serious? Stupid door. All right, y'all.
No, Mr. Davis, I still need one.
All right, so slow.
Maybe
you just write it back.
Ah,
Maybe it's on that cat.
Maybe the times are changing.
ah.
No, close.
I don't know why you did this on Monday.
Yeah, especially on the time change.
Yeah.
The next day you get got
Don't act the fool. Yes,
We're on these quadratics like this.
Too much.
Like they look clean.
Yeah, yeah, they do know that. They do.
But I don't
What are you
like
talking
that.
about?
That's beautiful. That's fantastic. Okay, okay. Let us continue. Let us continue. This is a very similar question to what we had before. Different wording, but you're basically going to do the same thing. Christian, turn around. Sorry. Okay. If I want to know if something is a factor of a given polynomial, all I'm doing is plugging it in. If I get 0 out, I'm good. Then it's a factor.
What if you don't get 0 out?
Then it's not a factor.
And what is it?
One of your strings is.
I don't care. All right. All I got to do is take my divisor, x plus 2. Just like before, we'll set him equal to 0. And we'll solve. Just pretty obviously, x equals -2. Christian, turn around. Right, just like before. What?
Then plug in -2 for x.
Bingo. Plug in -2 into your polynomial. P of -2. Don't forget your question.
I told you that 5 seconds.
Turn around for 0 seconds.
All right.
All right, don't forget the parentheses. I've watched way
Okay,
too many
great.
people miss this because they're not getting the parentheses. Include the negative inside of it. -2 to the 3rd plus 2 times -2 squared plus 3 times -2 minus 2. I'll pause a minute.
So many twos.
So many 2's. Oh, so many 2's.
You need to chill with coffee.
There's no pen.
No.
No, you actually do.
Well, I forgot to fill up my water, so what you gonna do?
Not drink coffee.
Drink more coffee.
Go to
We
the
can go
water
get
fountain.
you some water.
No,
How much coffee have you had today?
too much.
How do you know?
I can tell.
How do you know?
Because I'm pacing back and forth, and I can't stop.
That's a usual thing.
You know.
Well, he's doing it at an increased rate.
Okay, all right. If you skip the baby math, then you get, might be able to guess because it's an example, but you'll get it. Zero. If you get a 0, that is how you tell. When you see a 0, that's how you know. X plus 2. Oh, right. Before I write that math stuff I want to explain so I can start writing it on the board. If you ever see me do this,
What is that?
it's just like an arrow. That just means, like, if I get that, this implies the following. Because of this, that means what I'm about to write. Okay?
So
Okay.
it's like equal to.
So it's just a bad enough.
Sure.
Like because.
It more so means, like, because of this, that means this.
Cause and effect.
Cause and effect, yes. Sure. Something like that, yeah. Okay, so that means x plus 2 is a factor.
So is that like what you write for the answer?
In this case, I would, because all it says is determine if this is a factor. Yes, it is. It is a factor.
You can't just put yes.
No. Lazy and bad. We want to be specific. Okay. Are y'all ready?
No.
It's time.
And for what?
It's time for the actual rational root theorem.
No.
Oh, I've been waiting for this moment.
I'm so
Yes.
He dreamed about this last night, no doubt. You did. I know you. Yeah, you know you did. I know you did.
This one's gonna be like half a page, maybe.
Oh,
All right.
exciting.
The actual rational root theorem. Okay. Okay.
Okay.
Keep up with me now.
No,
All right.
not
If
yet.
Hey,
if p of x,
Is this a whole page thing?
this one's a lot. If p of x is equal to the following form, a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus, I wrote the wrong thing, a sub n minus 2 x to the n minus 2 all the way down to a sub 1 x plus a naught. So if we have a general polynomial of the following form there, did I word this right? Yep. If this is a polynomial function,
Oh, and I can see
what's he doing?
okay, so all I've written so far is if I have a polynomial. That's all I've said. If I have a polynomial. I should specify with integer coefficients. No fractions, correct. So to be precise, the integers is any positive or negative whole number. So it could be 2, 5, 20, 37, or it could be negative 25, negative 117, anything like that.
Okay.
No fractions. No square roots.
I like that.
None of that scary business. Okay, so if I have a polynomial of that form, then the following is true. Then all possible rational roots will be of the form this is the important part.
Why did the word get bigger?
Because I'm excited. Because of the form x equals plus minus p over q,
Okay.
where p is a factor of a naught and q,
Can you slow down a little bit?
I'm almost done, almost is a factor of a sub n. And that's the rational root theorem.
I heard Q. I think that should be a route.
This is one of my favorite theorems.
Well, I'm not liking it.
It's a joy to
How
behold.
was your dream about this last one?
It's a joy to behold.
Oh, I thought you said.
I thought that's what I thought he said.
What?
It sounded like you said it's a butthole.
I guess in a sense it can be from time to time.
What?
I thought it was okay.
There's actually merit to that question. It's same time. Okay. Yeah, so definitely write this down, obviously.
Is that
Oh, there's
Q
more?
over Q?
Oh.
Mm-hmm. That is equal to P over Q. David, you have a question, or are you just in distress?
No, I'm missing.
Okay.
You.
Yes. Can I hold my hand still?
Yeah.
No more.
Why?
Do we need to give you like
Ah.
intoxication test?
Ah.
Okay, like breathe into this thing.
Guys, don't worry about my caffeine intake. Worry about the rational root theorem.
We care about
Taking intermittent.
Hey.
If he kills over, then he can't.
That's
All right,
Let's spike his grades.
guys. I want your lives to be as easy as possible over the next 2 weeks.
2 weeks.
Guys,
Do we have this
this is
down?
going to take you
No.
This was dream
Buckle down.
on me.
Jake.
We're going on a journey
Oh,
Are we going on a trip?
in our favorite rocket ship.
Oh my goodness.
Going to the psych ward.
Okay.
I'm not done.
Sarah.
So,
Sarah.
Oh, no more talking. No more talking.
I love that.
oh, finally.
Caffeine.
Also, like we
Okay, now I have a question.
Guys. Quiet, thank you. Yes, Sarah.
You used a lot in the description.
I did.
So, P is a factor. That's like the word a.
The art.
Yes, yeah. That's a good question, Sarah. This A right here is the regular old English word A. That is not a variable. Yes, David.
How much vodka is in your coffee?
Excuse me?
You heard me.
None, David.
He's got 50.
None.
Respect the question.
Mr. Davis is speaking for some more. I think it's pretty moving on mine.
Okay. Oh, yes, Hannah.
Yes, thank God.
Definitely have viewers.
No.
What?
The A's can be equal. They don't have to be. The N's are all different, and the X is all the same.
Woodrow, wake up.
Wake up, wake up.
Guys, I can't hear Hannah.
This thing's really messy.
It ends with a certain number. So, like, if I set n equal to 5, I'd have a 5 here, but then obviously I'd have 4, 3, 2, 1, so all the exponents are different.
And wake up, Woodrow.
Yes, I'm sorry, yes. Yeah. Yes.
You make sure Woodrow's up and has all that written down.
I can see he's up. Okay, guys. All right. It's time to do it. It's time to actually use it.
Pay attention.
Head up.
This right here is the most important thing you'll write down today. Okay. We are going to. Does this say solve? Did I do one where it said solve? Oh, we're just factoring today. Okay. We're gonna factor p of x equals x to the third minus 3x squared plus 5x minus 6. Such simple yet deceiving directions.
Okay.
He speaks in riddles.
Yes,
So is this going to be our homework?
Oh yeah.
No.
Oh yeah.
Next one.
Chat GPT, here you come.
Y'all can do this.
So why is this cool for the homework that we had last
No. Let's pay attention now. Okay.
GPT, here we come.
Here's some things we're gonna do. Give me 1 second. Let me identify some things here. Okay. This right here is important. All of your possible factors look like this. So I start with P and Q. I start by figuring out what in the world that means. Okay. P is a factor of A naught, A sub 0. That appears right here in my big ugly polynomial.
So at the very end, so the constant.
Yeah. Oh, Kaylee, that was perfect. At the very end, the constant. That is 100% correct. P
The remainder.
is a factor of this guy. A naught is equal to 6. And I know some of you might scream at me. Why not minus 6? It's because it actually doesn't matter for this process, which is nice. Just nice.
So we could put,
You could put it there. You don't have to.
Because it's going to multiply.
so it could always be the positive.
Put simply, it just won't affect much. Yes, Cole?
We could always be the positive.
Okay. In a similar fashion, Laura, pay attention. In a similar fashion, I need to know what a sub n is, because that is what q is related to. A sub n is equal to my leading coefficient, the number out front.
So 1.
So 1.
So AN is the leading
So
coefficient.
we're gonna
Yes.
go circle that. We're gonna go there.
In translated into like basic English, this is the number at the end. This is the number in front. If you don't like the phrase leading coefficient, just think number in front. It's that simple.
I wonder if Isaiah's laughing.
Oh, I'm sure he is.
Maybe crying. I'm not sure.
Is Isaiah awake?
Is he watching?
What if he has a
Is he
question or
watching?
something?
Oh, it's so hot. Okay.
Oh,
Okay. All right, guys, stay with me now. This is gonna be a long problem.
I know you.
Now I need to list out P and Q. P, okay. Factors of A naught. In this case, factors of 6. Factors of 6. 2 and 3,
1 and
Don't.
6.
exactly. Don't forget about the obvious ones. So 1, 2, 3, 6. Now something I'm gonna do here
Oh yeah, because 2 and 3
that's
factors.
it's not like mathematically strictly required. This is just a step to help your memory. Whenever I list these out, see this plus minus here?
Yeah.
I put a little plus minus next to all these guys
So
just to remember that I need to have it there. Don't stress too much about like, oh, this is more work. Oh no, this is just to like help my memory. I need to remember that that is there. Okay.
Junior's the live chat.
1.
Very similar with Q. Factors of A sub n. What are the factors of 1, y'all?
1.
1.
1 and 1.
Just 1.
Negative 1.
But I will put plus minus 1. Okay. This next step is also important. All of your possible rational roots will look like this, P over Q. So I need to make a list of all possible rational roots. Yes, Brady.
Q is only gonna be plus minus 1.
Only plus or minus 1. Yeah.
Always?
1, 2, 3, and 6.
No.
Because that's the only factor.
Yeah, one at a time. Yes,
Yeah.
Brady.
Always 1?
Just 1. What's the only number that divides into 1? 1.
No,
So-
it's saying will it always be 1 in problems you get?
Oh
This would
no,
be the
this
one
could
in
be
front.
more. This could be more stuff. Yes.
So if it was like,
If it was 12, you do 1, 2, 3, 4, 6, 12.
Yeah.
Okay, so now I need to list out every possible combination of this, P over Q. Here is what I mean. All right, so I could do, before I write this, I'm just going to point so you can kind of see what it visually looks like to do. I could have 1 over 1. I could have 2 over 1. I could have 3 over 1 or 6 over 1.
So 1,
So
2,
1,
3,
2,
and
3,
6.
or 6.
Yeah, because I'm dividing by 1, nothing will change, but that's how this goes. Start with the first one, over this. Second one, over that. Third one, over that. So on and so forth. I would write that down, yes. So these are all going to be plus minus 1 over 1, plus minus 2 over 1, plus minus 3 over 1, plus minus 6 over 1. And as y'all just told me, that simplifies very nicely. Like so.
Ones are commas.
What?
Ones are commas.
These are ones. Those are commas. So there are ones and commas.
Delicious.
Okay, so these are all my possible rational roots. I won't write anything for a second. I'll let you catch up. So these are all my possible rational roots. Now I actually have to find it. This is normally a fun process.
I don't believe you. But,
Looks like we're done.
Oh, we are most certainly not.
Because I see factors.
I see individual factors of random numbers, but I most certainly do not see a factored form of that.
So we're
So
gonna,
we must continue.
we're gonna plug in, right, we're gonna have to plug in all the x's for
What
1,
is
2,
factor
3, and
form?
6
And why would we do that, Christian?
to see which ones are actually factors.
Christian Lepresti, that is 100% correct. I could not have said that better myself.
We have to get zeros for all of them.
Absolutely correct. Yeah,
You just plug them in so you get a 0?
exactly.
Okay.
Both of you, what you said, 100% right.
Yep.
What you do here,
Yep.
now you take your numbers in your list, you plug them in, and I'm looking for factors. So I'm looking for 0 to pop out of
There
this.
better be like 3 problems on the homework. This is a whole page of work.
I think there's like 7.
Is it 7 or 8? Because there's no one.
Then there are no rational roots. Okay.
Have the seniors gone over that?
Guys, they have yes. Guys, all right. Stay with me now. Stay with me. I gotta plug these in, and I gotta look for 0 somewhere. So if I plug in 1, oh, yes. To be clear, this is the guess and check step. This is guess and check. There is no way to know for sure by just looking which one it is. You really do just have to guess and check till you find it.
You've never condoned this before.
What?
You've never condoned this before.
I'm condoning it now. All right, so if I plug in 1 and I do all the calculations, the 1 cubed minus 3 times 1 squared plus 5 times 1 minus 6, you'll get minus 15.
That do our name.
No good. Bad. Not 0. Not what I'm looking for. Don't care.
Can you like slow down? for a second?
I will stop, yes.
Danny. Oh, Danny.
Danny.
Davis is just out of school. We're all about to die.
So this is the wrong answer because you got 15.
Yes, I did not get 0. I got negative 15. That's a problem.
How do you get,
Can you have more than one factor?
wouldn't it be
Yes, you can.
negative?
Should be negative 3.
Oh.
Yeah,
So
5
one
plus
is
1
negative.
is 6, and
Yeah, Junior's right. That should be negative 3.
Still not a factor.
Thank you, Junior.
Still not a factor though.
Still not a factor, though. Yeah, that's me, like, wrong. You don't have to put that.
That's not correct.
Yes, it is not correct. Okay. But if I plug in 2,
That is what we get. We get 0.
we get 0, yes.
So is there ever only going to be 1 that equals 3?
Yeah, about 6.
Sometimes there's 1 that equals 0. Sometimes there's...
So we have to go
Yeah.
through and multiply all of them.
Oh, yeah.
You
No,
can't just
thank
like
you.
get one and go on.
Progress mechanical.
Oh, wait, no. I think I accidentally confused somebody. So, during this process, you don't have to find them all. You just need to find 1. We just need to find 1. So I found the one that gave me 0.
Wait,
Okay.
what do you do? You do negative 2 as well? Like in the picture?
What?
You do plus minus 2, right? You do plus minus 3, you do positive 2, you do negative 2.
Not necessarily,
What is that?
because of this sign right here.
Like if you were plugging in and testing everything, would you do the negatives as well?
Oh, I'm glad you said that. Yes, Junior, you would. So, like, checking this list, y'all see this plus minus on all these numbers?
Yes.
So you check the positive and negative of every number. Yes, Jackson.
So Q,
Guys, quiet. Yes, Jackson.
the number in front,
Yes.
if it was like 6, you would have to do like all of
Yes.
them.
Yeah.
That's French.
To be clear, though, Jackson, you do it until you find a 0. You don't need all of the zeros, just 1 0. Yes, David.
Okay, so there, I'm guessing for steps up with the PQ equals whatever, there can be fractions for the plus.
Oh, yeah.
ones. Yeah,
Oh, yeah.
so that makes it even.
We're starting not awful. I won't do that yet.
There's
So you
definitely gonna be
use the
fractions in the
fractions.
homework.
Okay.
I'm getting.
Okay. I'm not starting out that bad. Yes, Chris.
And the first 0 you get is the one you keep.
Yes. There are normally more than 1 0. You only need 1. Okay. The following sentence I'm about to write is important. Once you find this 0, what that means and what you should immediately write down. My little fancy arrow. The 0 means the following. X minus 2 is a factor.
Factor of what?
That's a good question. I should have specified. It's a factor of p of x.
It just means that.
That's the word I was searching for in my head. Thank you, Aaron.
Could you
Yes,
just do
this
3
means
dots?
therefore, yes.
Can you just do three dots in your triangle?
Why do you know that?
Because
Mr. Price?
no, I think
Mr.
it's
Price.
like Kalinda's.
Really?
Right.
Yeah, yeah.
No, I
That's
think
a
it's
weird
right.
thing to know. Yeah, this means therefore.
Okay.
Wait, Mr. Davis, why?
I think she wrote one.
So guys, this is an answer to your question, Sydney. What's happening here? There's not math going on that like turns it into this. What's going on is because I know this is true, that means this statement is true. One statement implies the other.
So if we get 0 for like another problem, and let's say we plugged in 3 and it got 0, it's still going to be x minus 2.
No. So if you plugged in 3 and you got 0, what that would mean is x minus 3 is a factor. That make sense? Okay. Yes, Riley. Why is it x minus 2 instead of x plus 2? Because when we plug in to these functions for remainders and factors, we have flipped the sign, so I need to flip it back. Wording it that way, does that make sense? Okay. All right, I've got the factor. Now I get to do synthetic division.
Yay.
Because I know one factor, but I need the other factor, so I gotta do some synthetic division.
But
Yeah, he's probably so big right now.
so you put x minus 2 on the outside, and he puts the little thing on the
Yes.
inside.
Yes.
Yay.
Question.
Division.
One moment, let me say one more thing. You can do long division or synthetic. Does not matter. I don't care. I will never force you to do one. I'm always going to do synthetic, though, because it's faster. Okay. So I need to divide p of x by x minus 2.
So we
I will write that in English here. Divide p of x by x minus 2. Yes, Christian.
Did you write it out as x minus 2 because, like, if you set it to 0, then you get 2, which is the factor?
That is exactly correct, yes.
Wait, the remainder, whenever you get there, it should be like 2 over 2.
The remainder is 0. Because look here, Junior. By the remainder theorem, if I plug in what I'm dividing by, whatever I get is the value of my remainder. So I got 0 as a remainder. Okay,
Leave a check in.
so I got to do this division.
Probably.
So we're doing x to the third minus 3x squared
Maybe check in on the video.
plus 5x minus 6 divided by x minus 2. Right, we're going to run through that synthetic division real quick. I'm going to do this pretty quick. Don't freak out. Just my upside down box. We remembered upside down box. Laura, you look terrified. Yes, this is all the same problem. Don't worry, I'll let you know when you're done. Okay, real quick, synthetic division. Drop this down. Yep. So I get 2 minus 1 minus 2, 3, 6, 0. Done. Good job, Drew. Good logic check. Right here, this tells me I've got a remainder of 0. So I better get a remainder of 0 here.
You better.
You better. If you don't, you're screwed. Watch out for that.
Watch your language.
Eh.
He said the S.
It's only mild today.
He said the S.
All right. Don't forget your columns either. This is your remainder column, constant, x squared. So when I come to write my answer, I'll do it right underneath. It's going to be x squared minus x plus 3.
Are we done now?
I just got to write one more line. Okay. We did the synthetic. that tells me p of x finally can be factored of the form x minus 2 times x squared minus x plus 3.
You missed
Then-
your little arrow.
Wait, is that the number 33 thing, Mr. Davis? You said factor out
What?
on the homework.
Wait, how
Or
did
that
you get the thing that
is
you
that
wrong?
Yes,
that
yes.
one you mean?
On
It?
that specific problem, Junior, there's a much easier way of doing it, but this works for all cubics. I heard somebody else. Yes, Marley.
So it's the x minus 2 that we divided by.
What?
Then
Stands for remainder.
Oh, yes. R for remainder, yes. That is my final answer.
X minus 2, and you got the answer.
Now, y'all, I know y'all have been so very good today. Thank you. I appreciate it. I really do. I'm proud of you. I have another problem to do. I don't think I have time, but there are a couple things I need to mention before I lose you completely.
20 minutes isn't enough time.
Just Dad, listen. All right, this is my final answer in this case. But what is this?
Unsolved.
That is quadratic.
Thank you, Junior. That's a quadratic. Quadratics can be factorable.
No.
In this case, it's irreducible. Like, it's not possible to do it. Most of the time it is, though. And when it is, oh, you bet you're going to factor it. And if you don't,
On the homework we have.
oh, yeah. Oh, yeah. Oh, yeah.
Can you take away 2 problems?
That's it. 4 grams of that.
Two. To be
That's correct.
to be clear, to factor this here, you know how to do that already. That's just factoring a quadratic. That number times the front, that whole process. Okay, so yes, factor this part if you can. If you can. All right. Let me see.
Do you just know it's irreducible already, or would we have to just?
You would. Oh, good point. I know it's irreducible because I tried. You would have to try and tell.
What?
Okay, guys. You were good today. I'll give you the option. I have one more problem.
No.
Would it benefit you to have a worked exam?
It would benefit, but we don't want to do it.
All right. Here's how we're gonna do it then. I won't be as detailed, but I'll at least write the solution down so you have the worked process.
We might as well just not do it because if you're not gonna be detailed, I'm gonna be lost.
Oh, this one.
What I'm saying, okay, in that case, what I mean, I will explain, but I won't write you a book. That's what I mean. I'm gonna do it.
Don't erase that.
That's very good.
All right. Where am I not erasing?
You can erase this.
Okay.
Why don't you just do it how you normally would? Don't say anything, and I want to see how quick you can do it.
How? Well, I mean, I'm kind of copying it.
Done. That's
Okay. So my second problem was this: factor p of x.
No, we've already done 4.
Ah, damn.
So wait, so this is another rational one?
Yeah. Yeah.
Can you do a homework problem?
No.
That's not nice.
Excuse me.
Delish.
Okay.
Thank you.
So you don't have to label everything at the start. I recommend it though.
But Caesar's like.
So a naught. Laura, what's a naught?
Deleting.
It's not easy.
We know? Do we not know?
I know.
Braden.
It's a 1.
Negative 1.
Yeah, the one. Yeah. -1, +1. For this, it doesn't matter. One.
All
right. A and David. Yes. Good job.
Say,
All right.
That's.
Uno.
P.
Dos.
Fact. What?
Quattro.
Eh. Okay. P is factors of my leading term. So plus minus 1. Excuse me. Excuse me.
Oh, Dave.
I'm very thirsty.
Go drink your coffee.
I ran out of coffee.
Drink your hands.
I forgot to fill it up. Okay. Q. That is factors of 2. So plus minus 1, plus minus 2.
Wait, where'd you get those?
I used
The factors.
my noggin.
Factors.
Huh? They are the factors. Okay. I got to list out my possible rational roots. Plus minus p over q. For this problem, they're going to be 1 over 1 and 1 over 2. I need to say that again.
Sure.
1 over 1, 1 over 2.
1 over 1 and 1 over 2. Plus minus 1 plus minus 1 over 2. So yes, a fraction can appear. Okay, now I need to guess and check a factor. I could try 1. It will fail. You will get 4. You could try minus 1, and you would find it would work. This would get 0. Again, I skipped all the steps, so
minus
calculate.
factor. Why didn't you do -1?
Because that's a good question, because if it is in this list, it could be a root. So I need to check. All the numbers you plug in here come from this list of numbers. So the full list of what you're checking here is +1, -1, +½ -½ Okay, here you plug in, you find out what happens. If you plug in -1, you get 0. That tells me, don't forget to kind of flip this sign. This means x plus 1 is a factor. So I got to do some synthetic division. So if I do that, I'll have -1 outside the box, and then my stuff right there. 2, 3, -1. We'll divide that real quick. This will come down.
Wait, would it be 0? Because there's no Livestream.
Oh, you're quite right. Thank you, Junior.
Oh my gosh.
So if we synthetically divide it, we'll get that. You've got remainders, constants, x's, and x squared. So you get 2x squared plus x minus 1. That tells you that p of x must be x plus 1 times 2x squared plus x minus 1. Sydney has noticed something correctly. This resulting quadratic is 100% factorable, in which case we don't factor it. For stuff like this, give yourself some room, like come off to the side and write it. Before I do, I'll wait for y'all to catch up.
One drop.
A little bit. Okay, we'll put it up here. Just to help me factor this, I'm going to set it equal to 0. It doesn't really matter though. Okay, factors of -2 that add up to 1. I reckon that's going to be -x plus 2x, like that. Then you group. Then you factor. Here you factor a 1 out. Ooh. So we get x plus 1 times 2x minus 1. In 2 more lines, I promise, and I will stop. All of this will be x plus 1 times x plus 1 times 2x minus 1. And I can write that as x plus 1 squared all times 2x minus 1. And that'll do it.
Okay.
I'm confused why I did 2x squared minus x plus 2.
Right here. This is me doing the whole process of -1 times 2 is -2. Factors of -2 that add up to 1 are 2 and -1. So I plug these back in. -1 is right here. +2 is right here. Doing that process, just doing it quickly. Yeah, that'll do it. Thank you guys. Excellent work today. I'm proud of y'all. You stuck with me. Excellent work. Yes, you may go to the bathroom. That is all I have for you today. I will not make you do classwork in 5 minutes. You do have that homework. I cannot stress enough. If you are stressed out and you cannot figure something out, Come see me. ASAP.
Yeah.
Yes, due
Study-
Wednesday.
Study hall's gonna be full. on
Test
Saturday.
correct. Yes, you may go. Test corrections next Monday. Don't worry about that till next Monday. Yes, Jesse. Yes, you might go to the bathroom.
Need to use the restroom.
What? What's going on?
You say goodbye.
Goodbye, Isaiah. Please feel better.
I need to use the restroom.
You need to go to the bathroom. Go to the bathroom.